Well, we've made it to the last slide of this section. First we have an example of using the rules. And then we have a new rule here, the complement rule, that says the probability of the complement is 1 minus the probability of the thing. So let's get this done. So here's a table from the census in 2013. Here's how many millions of people fall into each of these 10 categories. Never married male, married male, widowed male, divorced male, separated male. Never married woman, widowed woman. I don't think they call it widowed, but okay, widowed woman, divorced, and separated woman. And I did us a favor, I totaled all of these values. So that's what this is. So that would be, this is 15 years or older. So that's the number 15 years or older in 2013. And then we're going to need some other total, so I added this and this to get that, added this and this to get that. I guess I could have done that on the fly. Then I added up all the men to get 122 million. I added up all the women to get 128.8 million. I mostly did that to make sure this number was right, so if I add these two together, I get this. So they were computed separately, so that's a double check. That's probably okay. So we're randomly choosing a person from this population, and so the probability of choosing a particular kind of person is just the fraction of the population that's that kind of person. So the probability of choosing a male will be 122.5 over 251.3. Okay, and it's not that I really am curious about the answer, but I guess I should write it down. So that's 0.4875 rounded. And widowed, it's this 14.3 million out of the 251, so 14.3 over 251.3. Okay. Okay, so that's 0.0569, so about 5%. And divorce is 25.4. So that's 25.4 over 251.3, 0.1011, rounded. Okay, so and then we're going to use the rules. Widowed or divorced. So widowed's here, divorce is there. They're disjoint events. You can't be widowed and divorced at the same time. Or maybe that would just be too unpleasant. I don't know. And so the way they're collecting it, all these categories are mutually exclusive or are disjoint, I guess we could call it. So if we've got two disjoint events, the probability of being in one or the other or both, of course you can't be in both because they're disjoint, would be the sum of the probabilities right there. And so we could just do that. The probability of widowed is 0.0569, and the probability of divorced is 0.1011. So we get 0.0569 plus 0.1011, 0.158. And then male or widowed, here's male, it's this green circle here. Here's widowed there, this purple circle there. So this particular quantity, widowed and male, belongs to male, also belongs to widowed. So male or widowed can't be divided into male and widowed separately because they're not disjoint. They share outcomes. And so we use the general addition rule, male plus widowed minus male and widowed. Male and widowed, this one here, is 3.1 over 251.3. So 3.1, which is here, divided by 251.3. 0, 1, 2, 3. So we'll get male 0.4875 plus, that's not a 7, it's a plus, without 0.0569 minus 0.0123, like that. Okay. So 0.4875 plus 0.0569 minus 0.0123. Make sure I did this more or less right. Looks all right. So 5321. Seems too big, but it looks right. Okay. 0.5321. So that's completed our example of probabilities of OR with disjoint events. OR can be considered union. Or with not disjoint events, and OR is still considered union, and you have to subtract off the double count. And then down here we've got the complement rule. So the complement rule says the probability E complement is 1 minus the probability of E. And here's a picture of E and E complement. So E is a collection of outcomes. E complement is the outcomes that are in S that don't belong to E. So in a Venn diagram sense, you can shade it like this. And since E and E complement encompass all possible values, and E and E complement are disjoint, they share no outcomes, the probability of E plus the probability of E complement should be the probability of E or E complement, but that's everything, so that should be 1. And then you can rewrite that any way you want. Here we rewrote it like this. You get this. Okay. Just subtract off probability of E from both sides of that equation, and you get that complement rule. So here's an example of using the complement rule. 52% of Americans have played state lotteries. So if we set E equal to the the event that you pick a lottery player, then probability of E should be 0.52. Find the probability a randomly selected American has not played a state lottery. Well, that'll be E complement. That'll be the probability you don't pick a lottery player. And the probability of E complement is 1 minus the probability of E. And 1 minus 0.52 is 0.48, like that. And you really wouldn't have even needed the complement rule to know that, because if 52% of Americans have played state lotteries, then 48% haven't. And since 48% haven't, the probability you pick someone who hasn't is 0.48. So somehow the complement rule is not very mysterious at all, where this general addition rule requires a little more thinking. But if you think about how these different events overlap, you can see I can't just add this probability to this probability because I'm double counting this group here. So subtracting it off will keep you from double counting it. Here's the subtraction here that happens in the general addition rule. Okay, I think we finished this section. And I'll see you when we move on to the next one. And here we go.